All right, the definition of a function states that a function is a relationship in which each element of the domain pairs with exactly one element of the range. So one domain can only correspond to one element in the range. So think about this. One input yields only one output. One input yields only one output. Now, several inputs can yield the same output, but only one input can have one output. All right? So if we look at examples, if we have a domain of -3, 0, 2, and 4, if we put in -3, we get out 5. If we put in 0, we get out 3. If we put in 2, we get out 2. Put in 4, get out 1. We can look at it as a graph. As we go along, each input only has one output value with it. One input comes to one output. So let's see if we can determine if each of these is a function. In our domain, we have -2 maps to -3, 0 maps to 6, 3 maps to 6, and 4 maps to 9. Now, let's think. Again, a function, which is what we're determining, a function is a relationship in which each element of the domain pairs exactly with one element from the range. So does each domain only have one range? Yes. This is a function. Each element in the domain has one output. Each domain has one range. So if we look here, we have 1, 4, 3, 2, 5, 4, and 1, -4. Is this a function? This is not a function. Why? Let's look here at 1. 1 pairs both to 4 and -4. Remember, to be a function, one input can yield only one output. We put in 1 and we could get 4 or -4, so that's not going to be a function. One way, if we're looking at a graph, that we can tell if a graph is of a function is to perform the vertical line test. If we move a vertical line, meaning it's going up and down, through the graph of a relation, and the graph does not cross more than once, the graph can only cross one time. If this vertical line intersects the graph more than once, it is not a function. So let's look. We have this first graph of a parabola. If we put our vertical line through once, great. Yes, this is a function. Let's look at this second graph. None, that's okay. None, that's okay. Once, twice, twice, twice. No, this is not a function. It does not pass the vertical line test. The graph intersects this vertical line more than once. So if we think about it, this point here has outputs there and there. Not a function. Let's look at this third one. We have 1, we have 1, we have 1, we have 1, we have 1. We have a little special event here. Notice it includes this bottom dot, but not this up top dot. This is okay. This is 1.1.1.1.1111111. Yes, this is a function. It does pass the vertical line test to be a function. Now, one thing we can do with functions is we can evaluate them at certain values. So let's look for the function f of x equals 2x minus 3. Our goal is to find each value. So let's find when f equals 4. So we're going to evaluate the function at a certain value. So what we are going to do is we're going to use substitution to go from the fact that f of x equals 2x minus 3 to say that f of 4 equals 2 times 4 minus 3, which means that that equals 8 minus 3, which means that f of 4 equals 5. Our function with an input value of 4 is equal to 5. Now, what if our input is not just a single constant value? What if our input involves another variable? That's fine. So if we wanted to find f of y plus 2, what we would do is we would take our original function, f of x equals 2x minus 3, and plug y plus 2 in for x. So that means that f of y plus 2 is going to equal 2 times the group y plus 2 minus 3. We'll simplify, we'll distribute 2y plus 4 minus 3. We'll combine like terms to see that f of y plus 2 is equal to 2y plus 1. Now, if we have something on the outside of it, so if we wanted to find, not find f of 5 plus 3, what we're going to do is we're going to take f of x, which is 2x minus 3, and then when we do f of 5 plus 3, we're going to take 2, evaluate the 5, minus 3, and then we're going to add 3 to the entire result. So we're going to evaluate this being 10 minus 3 plus 3. So we have 7 plus 3, which is 10. So f of 5 plus 3 is equal to 10. We don't simplify it any further. We don't need to do anything else. F of 5 plus 3 is equal to 10. Alright, let's look at a little bit of our practice. So on page 207, numbers 21 through 43, just the odds, so the answers are there for you to check. The answers are there for you to check. But please, please, please do your best not. Also, I need to show some written explanations. So, the directions say to determine whether each relation is a function and to explain. So I want you to write a little bit about why each is a function. So if we look here at 21, we have in our domain 1, 4, negative 8, 3, and 1 maps to 4, or 1 maps to 5, sorry. 4 maps to 5, 4 maps to 6, negative 8 maps to 8, and 3 maps to 7. We look and we see that 4 maps, this 4 input maps to 2 outputs. So therefore this is going to be not a function. 1 input cannot yield 2 outputs. And there's our rationale of why this is not a function. We skip some space, always feel free to take more room, and then we look at 23. Have fun.